Alright, so let us go over the rest of the questions in triangle packet. So here we need to prove that line AB is parallel to line DE. Now, then in one thing is we need to realize how they are parallel. Usually it could mean that they have alternate interior angles or corresponding angles, or things like that would be very good point to start off with. Now, given that in these two triangles, C is a midpoint. C is the midpoint, that means this one is equal to this one, and that one is equal to this one. Because C is midpoint of DB, which makes BC and CD to be equal to each other. AE, which then makes AC and then CE to be equal to each other. Now, as soon as you realize that by the given, then we also realize that angle is congruent to this angle. It tells us that these two triangles must be congruent. Therefore, we can say this angle is congruent to this angle by CP, CTC. But one other thing that we get to realize is these two angles are also alternate interior angles, which makes the line AB parallel to line DC. Alright, so next question. In an isosceles triangle, notice that B is common here. That means when we draw an isosceles triangle here, we have B will be right on top, and A and C can be this way, where these two sides are equal to each other. That makes angle A to be congruent to angle C. And that's right here. Number 23. Now in a triangle, we have these three lengths of sides. Which statement is true about? Now, since we are looking for the angle versus the length of the side, angle that's opposite to the longest side will be the biggest angle. So in that way, so if you have something like this, we can say this can be 8, and this can be 12, and this can be 13, where 13 is P, R, and then Q. Then I believe everything works out. Okay. Now here, opposite of 13 will be the biggest angle. That means Q is the biggest angle. So we're looking at these two options, and then the second biggest angle will be opposite of the second longest side, which is P. So therefore, our answer will be choice number 1. All right, here, line segment AB is tangent to circle O, so that means here we have circle and the line tangent to that right here. And which type of triangle can always be formed when point A, B, O as in the center of the triangle in this way? Then one thing that we get to realize is the radius and then the tangent line segment always create a right angle. Therefore, we're going to have right triangle in this case. All right, next. In this case, in one relationship, since this is 2x, we can say one portion, only the upper half will be equal to x. Since it's an isosceles triangle, given that altitude forms a right angle with its base, then we get to have 13 squared equals x plus 7 squared plus x squared. So that's how we can set it up. But you know that on the other side, if you remember the popular triple, Pythagorean triples, then we could have seen something like 3, 4, 5, or 5, 12, 13. Chances are that this might be 5, 12, 13, but we'll see very soon by calculation here. So here we have 169. Now, when you square x plus 7, notice it is not just x squared plus 49. Remember, we have the middle term, which is plus 14x. If you do the distributive property correctly, then we would have x squared plus 14x plus 49 as the expansion of x plus 7. Now, as we continue plus x squared, and when you combine everything, and subtracting 169 from each side, we will have 2 x squared plus 14x, and then we will have negative 120. Now when we factor this one correctly, we will have 2 and x squared plus 7x minus 60. Now, when you factor 62 numbers multiplied to negative 60, but add up to 7 will be x plus 12 and x minus 5. So this tells us that x can be either negative 12, which cannot be because length of the side cannot be negative, or 5. So therefore 5 would have been our answer. Now, given that, what is the length of the base? Base will be, since it's 2x, then the answer will be 10. Alright, here we have which statement must be true. Now, angle bisectors. Now, angle bisectors are concurrent. That means when two angle bisectors meet up, the third line meets with the same intersection would have been also angle bisector. Because once again, angle bisectors are concurrent. That means as soon as we have two angle bisectors meet up at a point, that point must be passed by the third angle bisector, even though it didn't say it, because since it is passing by the same point, it's got to be the angle bisectors. Then we get to realize angle ABG or let's see, AEB. AEB is equal to AEC. Not quite. We have no idea about that. DBG, okay. And then EBG, that's right. So therefore the answer will be choice number 4. Alright, so we have two chords intersecting, and then which relationship must be true. Now, when you look into this one, we realize that this angle is congruent to this angle because they share the same arc, so as this angle is congruent to this angle because both angles share the same arc. Then as soon as we say that, we will realize that these two triangles must be similar. So maybe if you have to look at AEC upper triangle is similar to BED, which is the bottom triangle, and that is the correct answer. Here we have BE is 7 and AB is equal to 10, and then BC is equal to 13. But since PE is mid-segment, that means this will be the half of the bigger side, so this must be equal to 14. So that makes the perimeter of the triangle ABC to be 10 plus 13 plus 14, which simply ends up in 37 becomes our answer. Alright, so since these three angles must be add up to 180, so therefore angle F is 12 degrees less than twice of E. So let's call this one as angle X. That means angle F would have been 12 less than twice of the angle E. So if you have to add up these three, then we get to realize X plus 2x minus 12 plus 90. Now, this must be equal to 180. Then we have 3x minus 12 must be equal to 90 also. Then 3x must be equal to 102, which makes x to be equal to 34. Alright, now, that's our answer. Let us move on. Number 30. So here we have a line segment AB. It's congruent to AC. Now, angle B is 40 degrees, which we realize that angle C would be also 40 degrees because this triangle ended up being the isosceles triangle. Now, then how do we find the angle A? Well, that's kind of obvious here. We call it x. Then we have x plus 40 becomes 180, which leads us to have x as 100 as our answer. Choice 4. Alright, let us continue. Diagonal AC is drawn in a parallelogram ABCD. Okay, so let us draw a diagonal here. A, B, C, D. Now, AC is the diagonal drawn. Okay, which method cannot be used to prove that these two triangles? Can we use SSS? Yes, because this being the reflexive and opposite sides are equal to each other. So that is possible. All right. Next, can we have SAS? SAS here means SAS means angle has to be between them. That means we could have this angle. Opposite angles are congruent where we have opposite sides being equal to each other. As in, we have two triangles to be congruent to each other through SAS. How about SSA? But that is not possible because, in fact, you will realize later on next year that this will lead us into ambiguous case. Hence, we cannot use this as part of our way to prove the two triangles are congruent, because sometimes it leads us into two different triangles with the same condition. All right. Now, number 32. Which set of the numbers represents the length of... Now, in order for us to see the length of the triangle, length of side of a triangle is triangle inequality, where sum of two sides has to be greater than the third. Now, in order for us to look into that, one thing that will satisfy would have been this one, because in this case, when you add up these two, that's equal to 18. Therefore, that's not correct. In this case, when you add up these two, that's less than 24, which is not also possible. So is this one. So only possible answer will be choice number 3. All right, here we have midpoints, very popular figure, which we have to realize. AC is equal to 10. That makes this one to be 5. And AT is equal to 18. That makes this one to be equal to 9. And CT is equal to 22. That makes this one to be 11. Now, what is the perimeter of the parallelogram CDOG? So we're looking at this one. Then this is 11, 5, which makes this one to be 11, and then this one is also 5. So total we will have, when you add up everything, 32 will be our answer. All right, here we have, this is 36, 12. What is the length of AD? AD, what do we call that as x? By the ratio which we can set up is 12 squared would be in fact equal to 36x. Now, then in this case we have 144 is equal to 36x. X will be equal to 144 divided by 36. Then here we have x must be equal to 4. That becomes our answer. All right, here we realize that this is construction. If you have to look into this portion by itself, let us say. Now here we realize one line segment has been cut by same arcs. This is the picture of perpendicular bisector, meaning this one is three perpendicular bisectors cut through together, creating a single point, which ended up being the circumcircle here. Now, then we're looking at perpendicular bisectors. So there it goes. Number 4 is what we're looking at. All right, let us look at the next question. So these three, we just have to add up to be 180. Same idea, x plus 3x plus 5x minus 52 or 54 has to be equal to 180. Whoops. I guess I have to use the wrong. marker. Everything erases, yes. X plus 3x plus 5x minus 54 must be equal to 180. Now, then we realize 9x must be equal to 234. Now, then we get to realize that x must be equal to 26. That becomes our final answer. Alright, so now, soon as we realize this is 117, then if you have to call this one as x, we get to realize 37 plus x must be equal to 117. Then we can easily figure out that x must be equal to 80. Now, then x is equal to 80. This angle is 37. Then here we can call this one as y. Y is simply supplementary to a 117-degree angle, which gives us 63. So this is 63. Now, which side of the triangle ABC is the longest? Opposite of the biggest angle, which basically means AC, would have been our answer. Alright, let us move on. Here, which two statements identify corresponding congruent parts of these triangles? Now, in this case, what we are assuming is this. A is corresponding to X. That's what we are assuming. B is corresponding to Y. In that order, that's basically what we're looking at. C, of course, we are assuming that corresponding to Z in that order. Now, then, AB must be congruent to XY. You see that same portion, AB and then XY. And how about angle C and then Y? C is in fact all the way at the end, while Y is in the middle. Even if you have to look at a picture, C is here, Y is here. Seemingly they're not. So therefore, number 1 is not the answer. How about number 2, AB versus YZ? Once again, the location is not the same. So even when you look at it, AB and then YZ, you can visually see that they're not equal to each other. Alright, the third one, BC, we're talking about this one, and then XY, same idea, that they don't really quite correspond. The last one here, BC and then YZ, angle A versus angle X. And even if you were to look at this order, it would fit exactly the way it should. So therefore, choice 4 would have been our answer. Alright, here we have the perimeter of the triangle ABC is 36. Now, then equal to our triangle, each side will be equal to 12, which makes the smaller triangle have 6 and 6 and 6. Now, what is the length of EF? EF will be also 6. In two similar triangles, A corresponds to, once again, Z, C corresponds to Y. Then X must be corresponding to angle B. When you look at angle B, since A is already 50, C is already 30, then when you add them up, it becomes 80. Which leads us that angle B must be equal to 100, which is the same measure as angle X. Alright, so we have two conditions that's already given. What other information? In order for us to have SAS. Now, this one is already S. And this one is A. That means the other S has to be on the other side of the congruent angles. I mean, the other side of the congruent angle. So we have to have these two sides must be equal to each other. So the answer must be AG must be congruent to OL. That must be our answer for this question. Alright, the next one. Three sides are given. Smallest to largest. Of course, largest is opposite of the biggest angle. Biggest angle to line segment AC must be angle B. So angle B has to be all the way at the end. That must be, this should be our answer. Now here we have, as soon as you see this picture, you will realize about 2-to-1 ratio. So CG to GF must be 2x to x, where then CF, the entire line segment, is equal to 24. So 2x plus x must be equal to 24, which leads you to have x as 8. Now then, what is FG? I guess that's equal to 8. Here, how do you find this is the equilateral pentagon? That means measure of the regular pentagon. Measure of the one angle here becomes simply 180 times 5 minus 2, since it's pentagon, and minus 2 formula divided by the number of the angles, which is 5. Now, which will lead us to have 108. That means this angle must be equal to 108. How do you find the angle AEB? Since this is an isosceles triangle, these two, if I call this one as x, then this must be also x. So here we have x plus 108 is equal to 180. Then you will realize that 2x must be equal to 72. Then x must be equal to 36. So that becomes choice number 1. Alright, now, which ratio is also equal to 3-to-1 when the ratio of the length is 3-to-1? Angle is always 1-to-1. The ratio of the angle doesn't change. It's always 1-to-1. But B and F, we have no idea because they don't seem to be corresponding angles. Area is always a square of the ratio of the length. So this will be, in fact, 9-to-1. But here, perimeter, whether it be the perimeter, in similar figures, the length is always length, has the same ratio as the original, which is equal to 3-to-1 right here. Therefore, choice number 4 would have been our answer. Here we have CB is equal to 3, and then CA, entire length, is equal to 10. And then EC, which is equal to 6. ET, why don't we call this one as X? Then we have to have the corresponding part, as in 3 to 10, which is the part over whole, has to be the same ratio, 6, which is the part over whole, which is 6 plus x. Now, then we end up having 3 times 6 plus x is equal to 60. Now, when you multiply 3, remember you have to multiply 3 in both cases. We end up having 18 plus 3x, which is equal to 60. 3x is equal to 42, where x is equal to then 14. Now, that becomes our answer for ET. Alright, so here we have, once again, if you just look at one corner, you will realize that this is the angle bisector. Now, angle bisectors coming together, creating an incircle. So that is the intersection of the angle bisectors. Oh, there we go, choice number 1, right there. Alright, let us move on. Here, as soon as you see this picture, you should realize that this angle is sum of the other two. Now, and here we have 6x plus 20 must be equal to x plus 40 plus 4x minus 5. Then we have 6x plus 20 must be equal to 5x plus 35. And when you subtract 20 from each side and 5x from both sides, x will be simply equal to 15. Now, then, find, it says fin, but find the angle QPT. QPT, which is this angle, is then simply 6 times 15 plus 20. Now here we have 110 becomes our answer. Alright, now how are we going to find out the value of h? Here we're going to have in a couple of different ways. One way is, if you want to find out what b is, You can find it by 3 squared is equal to part, which is b, times the whole, which is 5. Then you will realize that b must be equal to 9 over 5. Now, then you can also find a along with that. Likewise, 4 squared must be equal to a times 5. Hence, a must be equal to 16 over 5. So how do you find h? H is equal to, h squared is equal to lines product of the other two line segments. So we have h squared must be equal to 9 over 5 times 16 over 5. Then then we get to realize 12 over 5. That becomes our answer. Of course, the simpler way, if you have to use the area formula, that's the second way, which is so much simpler. We get to realize 1/2 4 times 3. That's how we can find the area of the right triangle. If this one is base, the other one is the height. Is equal to 1/2, the traditionally 5 being the base and h being the height. Then 1/2 cancels out. We have 12, which is equal to 5h, where h is equal to 12 over 5. That becomes our final answer. Either way, we would end up getting the same answer. Alright, number 50. We have these three coordinates. Now, since we do not know fully what's going on, I believe it is very important for us to have the, for the graphic, for sketch it. So, here we have -1 comma -2. That seems to be the A. And then B is -1 comma 2. That seems to be B. And then C is 6. It looks like already it seems to be an isosceles triangle. Alright. That means angle A and B must be congruent. Yes, that becomes our answer. Number 51. Alright, so here we have median BF. BF is the median, that means AF must be equal to FC. Because that's what it does in the altitude. Of course, it creates the right angle. And then BE bisects the angle, that means measure of the angle. ABE is equal to measure of the angle CBE. So let's see any one of these two would have been coming out. AF. Okay, no. AF. FAB. FAB, no. ABF, ABF, no. Actually, right here, the last one. CF, which is the same thing as this one, is congruent to FA. So therefore, our answer will be choice number 4. Alright, so here this is 5, and then this is 2. That means this makes this portion EO to be 3. Then you get to realize that this is 3, 4, 5 triangle. So ED must be 4. We're looking at BD, that means this is also 4, which creates 4 and 4, 8 to be our answer. Now, here we have, since this is 6, sum of the two sides has been greater than the third side. Then we get to realize that 6 plus x, I'm going to call this portion as x, has to be less than 7 plus 18. Then we get to realize that 6x, oops, 6 plus x has to be less than 25, which makes x has to be less than 19. On the other hand, instead of 6 plus x being the third side, this can be the 18 can be the third side. That means we get to realize that 6 plus x has to be greater than 18 minus 7. 18 minus 7, which ends up being 11. That means as you subtract 6 on each side, this one has to be greater than 5. So we're looking at anything greater than 5 or less than 19, which would have been choice number 2. Alright, let us move on. In the diagram below, oops, I guess don't have a diagram. I guess I'll do this question later, I guess. Alright, two triangles are similar with a ratio of 2 to 1 in corresponding size. Now the area has to be square of that which is correct. And then altitude, because same as the length, 2 to 1, same thing. Perimeter has to be the same because of corresponding size, which is the length. The angle, on the other hand, has to be the same, not in the 2 to 1 ratio. Therefore, choice 4 will be our answer. Here we have, they want us to find our CD. Why don't I call this one as x? Then we get to have x squared will be equal to 3 times 4, where x must be equal to square root of 12. But when you simplify this one, this becomes 2 radical 3. There it goes. Our answer is that. Number 57, here, how do we prove the triangle ACE? ACD, that triangle. So let me try to draw that. ACD. We're looking at blue triangle. Now, the other one would have been the red triangle, BDC. So we have now, as soon as we have drawn that, you will realize that the DC is reflexive. Very good. One side is already done. Now, since AB is parallel to BC, since this one is parallel, two intersecting chords are also congruent. How about that? Now, the third one, I mean, there are many ways for us to prove this one. Oh, well, the third one that which we can do is this. This angle is congruent to this angle. Why? Because we realize that BD, measure of the arc BD, is congruent to this one. And then given that this is common in both intersected arc, so you will realize that angle DCB corresponds to this measure of the arc, including the congruent one. And then measure of the angle ADC also includes this common arc and also congruent arc. By the addition postulate, we can say these two triangles must be, these two angles must be congruent by SA. But there are many other ways of doing it also. Alright, with this, we'll just close up for today. And have a great time in studying. See ya.